this video, I'm going to be doing a walkthrough of a transistor circuit. Now here we are dealing with an NPN transistor. I have a resistor here, and I have a resistor here, and I have a source voltage here. I also have my transistor. I have a base, I have an emitter, and I have a collector. And we're going to see how all these parts play together to make this circuit work. First off, let's give these guys some names. We have this resistor that's connected to the base, and we have this resistor here that's connected to the collector. I wonder what we're going to name them. Why don't we name them RB for base resistor and RC for collector resistor? Now this Q down here, that's not a typo, that's just the symbol for transistor. Now if I have a base resistor here and a collector resistor here, I'm going to first off, dealing with the transistor, is determine what my base current is. In order for that to happen, I need to have a voltage. So let's assign a voltage. Let's go with 24 volts. I'm going to start with 24 volts. All right, now we need to figure out what the voltage is across RB. A transistor is basically like two back-to-back diodes. So what we're looking at here is a diode here that will be forward biased. And what is the volt drop across a forward biased silicon diode, you ask? It is 0.7 volts. So we will have a 0.7 volt drop from the emitter to the base always, if it's a silicon. If it's germanium, it's 0.3. Now, if we look here, we have a circuit that goes through here over to here. So if I have 24 volt source and I have a 0.7 volt drop here from the base to emitter, the rest of it must be dropped across RB, which, doing the math in my head, works out to be 23.3 volts. Next, in order to get the base current, we need to give this resistor a value. I picked 61.3 kilo ohms. Those ohms are kilo, yo. So we need to figure out now what the base current is. Using the power of Ohm's law, I can take voltage divided by resistance to get current. In this case, that's going to work out to be 380 microamps. They are teeny in their tininess. Now we have a base current now. And the nice thing about a transistor is you can take the base current and it can quote unquote amplify the current onto the collector. Now in this transistor, we're going to give this thing a beta, or an amplification factor, or gain. That's just the number we're going to use to multiply the base current to get our collector current. So let's do that. We're going to give it 100, beta of 100. Now we're going to take that 380 microamps, multiply it by 100, and we're going to get our collector current up here. Now it's not actually magically amplifying this current to that current, but in this video we're just not going to get into too much how that happens. Just suffice it to say that the current basically changes over here. So we're going to do that. 380 microamps times 100 gives us a new collector current over here of, that's right, 38 milliamps. Now that we have the current on the collector side, we're getting closer to the end. We need to figure out what the volt drop will be across the collector resistor. Well, in order for us to do that, we need to have a resistance. Because we have a current, we need to take the current times the resistance, again using Ohm's law, to figure out what the volt drop is across this resistor. So let's try that out. We are going to give it the value 500 ohms. So I've got 38 milliamps running across a 500 ohm resistor. That gives me a voltage of 19 volts. All right, so remember before I said that we had a circuit that was running this way. That's true. We also have another circuit which runs this way across it. So Kirchhoff's law still is obeyed. I've got 24 volts here. I have 19 volts here. The rest of the voltage has to be dropped somewhere. We're going to drop it like it's hot across the collector to emitter. And then we call that the VCE. So I'm going to take 24 volts minus 19 volts, and I'm going to get a voltage of 5 volts that I'm going to put across VCE. And there we go, 5 volts. And that's it. We've calculated the whole circuit out. So transistors, while they can seem a little intimidating at first, once you get the rhythm of it, it's not that bad. You take this voltage minus this voltage to get this voltage divided by this resistance to get this current times the beta of this transistor to get this current times this resistance to get this voltage minus this voltage gives you this voltage. Done and done.